Okay, let's look at question 5 now. So I'm going to, as usual, I'm going to give you hints. It's going to be a long weekend for you. So obviously this will be your homework over the weekend. So for those of you who have not handed in question 1 to question 4, please do so. Okay, so for this first part, from going from C2H4, that is an alkene, okay, going to a halogenoalkane. If you cannot see it, you can draw it out. Okay, so that's your CH4. And then what happens is that you are adding C2H5Cl. So that means you are adding H and Cl here. Okay, so that is not a dotted bond, that is just an erased bond. So please go back to your AS for this, okay, because this is in your AS topic. The second one is an alcohol. I can't spell alcohol. AlCOHOL, okay? Alcohol to halogenoalkanes, okay? So you go back to your alcohol notes. So you can see this question comes from a paper 4 question, and you can see that the first 2 questions already comes from AS. So you can't really run away from AS if you're taking only paper 2. Okay, so I've had one student who pointed out a good he or she has a point, because paper 4 also involves some of your AS knowledge. So he or she said, I might as well take 5 papers. Okay, at the same time, I'm revising for my AS. I'm also preparing for my A2 paper 4. Okay, so yeah, that's up to you. C2H6 is an alkane. If it helps, draw it out. Okay, you don't have to draw all the hydrogen. Okay, C2H5Cl. So that means one of the hydrogen has been replaced by chlorine. Okay, so this is from alkane to haloalkane. Okay, haloalkane is the same as halogenoalkane. Okay, next one is C2H4, is an alkene. This time you are attaching 2 chlorine. Okay, so this is different from the first reaction. In the first reaction, you're only attaching 1 chlorine. In this reaction, you're attaching 2 chlorine. So you start with a double bond with 4 hydrogen. I don't have space. And then you add 2 chlorine. I don't know if you can see it here. Cl. Okay, well, it still falls under the reaction of alkene to haloalkane. Okay, but you have to take into account that here you only attach 1 chlorine, here you attach 2 chlorine. Okay, so the reagents would be slightly different. CH3COO H2CH3COCl is something that you haven't learned, so I will just give you the answer. Can you please write it as Sockle to, oops, sorry, not there. Sockle to SOCl2 and heat. Okay, so that's something that we haven't covered yet. Okay, next one is you go from a methyl benzene. So this is a hint that you should look at the reactions of benzene. You are adding the chlorine onto the benzene ring. Okay, so when you add chlorine to the benzene ring, there's only one mechanism for that, but you need to, if you don't remember, you need to look up on your notes. So this is benzene, or more accurately, it's an alkyl benzene to addition of halogenation of your alkyl benzene. Okay, next one, you have a benzene ring, but your chlorine is attached to the side chain. Okay, the side chain is an alkyl group, so that means it must be the reaction of alkane. Okay, you see there's nothing happening inside the ring, so you cannot say that this reaction is electrophilic substitution. It has nothing to do with the ring. The chlorine is attached onto the alkyl group, so you need to go back to the reaction of alkane. Okay, basically alkyl is the branch chain of alkane. Okay, so that's question 5. Reagents and conditions, look it up on your notes, okay? Some of them will be, most of them will be from your AS notes. Question 6. Okay, so I think this is quite similar to the previous question that you have done earlier on. I don't remember which question, but I will just go through it with you quickly. Okay, so this is an alkene functional group, and then this is a benzene functional group. Both of them react with the same reagent. However, they have different conditions, of course, because even the reaction is different. Okay, so you just have to answer this question where it says the type of reaction. The type of reaction is, it has to be the full reaction: electrophilic substitution or electrophilic addition. Writing substitution alone is not enough, or electrophilic alone is also not enough. Okay, so please write it in full to be safe. Okay, hold on. Right. Write an equation to show the formation of the electrophile. That one you can refer to your notes as well. Each of these reactions involves an intermediate. Draw the structure of the intermediate. So you need to draw a carbocation intermediate. Okay, only by looking at the mechanism then you can figure out what the intermediate is. Okay, carbocation is a species that has a positive charge on the carbon. Okay, suggest why the product of the reaction between bromine and benzene, bromobenzene, is still unsaturated. Okay, so if we look at this bromobenzene, okay, what does it mean by unsaturated? Okay, this is bromobenzene, unsaturated. Now, saturated means it contains single bonds only. Okay, everything contains single bonds. That means it's already saturated. You cannot add any more atom in. Okay, but you can replace, right? Unsaturated means you still have some double bonds, right? So as you can see in the product of a bromobenzene, you still have that delocalized ring. Okay, this one, the delocalized ring, that still contains double bond. Okay, you can still add electrophiles here, 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 and here. 5 more possible positions for electrophile, except where the bromine is sitting, okay, because you cannot break the carbon-bromine bond. For the other carbons, you can still break the carbon-hydrogen bond, okay? Right, so the answer to that is, the reason why you don't break the ring of delocalization, or the double bond as we say, but it's strictly not a double bond in the bromobenzene, is because the ring of delocalization is stable. The ring of pi electrons, or you can call it delocalization in benzene is stable. Okay. Right. Next, that's question 6. Question 7. Okay, so let's have a look at the first reaction. So you have a dimethylbenzene, you add chlorine, and then you add light. Now, chlorine with light is the condition, UV light is the condition for free radical substitution. free radical substitution, subs, okay? Or I will say that this is the reaction for alkane, okay? So you just write down the product when one substitution occurs, okay? So that means the fact that I already told you that this is the condition for alkane, so you won't see any reaction happening in the ring, okay? No reaction happening here, but the reaction can happen here or here. So you just have to choose one, okay? So draw only for one mono substitution. If you look at free radical substitution, it is a chain reaction. It can go on until you finish all the hydrogen on your alkane, okay, or your alkyl group. But for this question, please just draw the product of a mono substitution. That means one. You replace one of the hydrogen with one chlorine, okay? So then the reaction with sodium hydroxide and heat is the reaction of halogenoalkane. Later on, you will see halogenoalkane. Okay, just write down the hint first, right? I cannot, maybe it doesn't make sense to you now because you don't know what the product is yet. Okay, the second one, chlorine with aluminium chloride. Now, that is a hint for the reaction on benzene ring. Okay, again, you only have to do for, oops, sorry. You only have to do for one substitution. Okay, the position does not matter in this case, because if you look at your, let's see, your methyl group, okay, it's in position 1 and position 2. This is 1, this is 2. And you know that the methyl group is electron donating, so it activates position 2, 4, and 6. Okay, so in this case, you have methyl sitting on position 1, another methyl sitting on position 2. So the 2, 4, 6 will be slightly difficult to predict here. So in this case, you do not have to worry about the 2, 4, 6 position. You just choose any one position that you like, okay? Again, mono substitution, that means only one substitution can happen, because as you all know, methylbenzene can actually undergo disubstitution or trisubstitution. Okay, HNO3 plus and H2SO4, this is a nitration. Okay, just write down the hints first for now. Right, next is potassium manganate. What is that? And heat. What is OH minus? It should be OH minus. So this is an alkaline condition of an oxidizing agent. So this is actually your oxidation. And you have two functional groups here, the alkyl and the benzene. If you look at your notes, only the alkyl will be oxidized. Okay. The benzene ring will not be oxidized, right? CH3OH plus concentrated sulfuric acid. This is the reaction of esterification. Again, esterification. Okay, so that's something that you have to work out. So you can see that an A2 questions involve AS question as well. Okay, like this one, free radical AS, halogenoalkane AS, esterification is AS, right? So maybe perhaps taking 5 papers in November will help you with your paper 4. Okay, so you don't completely forget your AS, because even if you study for paper 4 and 5, you cannot completely leave your AS stuff. You also need some of your AS knowledge. Okay. Okay. Right. Next. I hope you're done copying this down. Okay, please let me know if I'm going too fast. Okay, if you did not manage to copy down everything that I write, please let me know. Okay, I'm going to move on to the next question. Question 8. Okay, so question 8 is one of the steps involved will okay, so I will tell you the first reaction is halogenation of benzene. Halogenation of benzene. The next one is reaction number 2 is nitration of benzene. Okay. Wait, it's asking for you for the reagents for for reaction number 3. That one you haven't covered yet. So you will write suggest the reagents conditions needed for the reaction 3 in the above synthesis. Okay, so for this one you need tin plus concentrated HCl. Okay. So for that question, you only have to draw Y and Z. For part 2, we haven't covered that yet. Okay. Question 9. Okay. Compound R is an intermediate. It can be made from compound P by the following route. P is a C8H10. Okay. So from the molecular formula, I hope you can tell that. So the benzene, obviously, from here to here, you need a benzene ring, okay? A benzene ring is already C6, right? So since you have 8, that means you must have hydrogen here. Sorry, a carbon and a carbon here. So that's 1, 2, 3, 4. 4 hydrogen, okay, you need 10. 5, 6, 7, 8, 9, 10. Okay, so it's a dimethyl benzene. C8H10, you get a C6 from the benzene. 2 carbons make up your 7th and 8th carbon, and then you just count the number of hydrogen. Okay, step 2, step 1 is converting your alkyl benzene into a carboxylic acid. Okay, so this is your A2 stuff. Alkyl benzene to COOH. Okay, I will not tell you the reaction because otherwise it would be easy. Okay, step 2 is something that you have not done yet. So step 2, I will give you the answer. Step 2 is Sokal 2, just the same like the previous question, or PCl3 plus heat. Okay. Step 3 is also something that you have not done yet. So that sorry, step 4. Step 4, you have not done that yet in dry ether. Okay, actually step 3 is also something that you have not done, so I will draw it out for you. It's really difficult to find questions that are strictly on benzene only. NCH3 2 CH3. Okay, please draw the structure for that. You have not done that yet. You okay?
Yes.
Can I move on already?
Yes.
Okay. Right. So actually, there's nothing much for you to do on question 9. Basically, it's just the first step. Okay. Question 10. Let's see. You have, they're telling you, basically, the first part is just telling you methylbenzene can be converted to nitromethylbenzene by the addition of that nitro group. Benzoic acid can be converted into a nitrobenzoic acid in that position. Okay, so they're just telling you the position of the incoming nitro group. Okay, so that means when you have a methyl group, it activates the 2, 4, 6 position. Okay, in this case, the 6th position is being the 4 position is being activated. Okay, if you have a COOH, this is 1, 2, 3, 4, 5, 6. The 3 position is, how come I cannot write number 4? The 3 position is being activated, as you already know. Okay, so in this case, your nitro group will sit on the 3 position. Okay, CH3 activates 2,4,6, but your nitro group sits on the 4 position. COOH activates 3,5 position, but your nitro group sits on the carbon 3. Okay, using this information, suggest a structure for compound C in the following synthesis of a 3-bromobenzoic acid. Okay, so you need to find a compound C that can help you attach this bromine. Okay, so the first thing I would suggest you, the first step is the addition of bromine. Addition, sorry. No. The first one I said, the first one I think you need to change CH3 to COOH. Okay, CH3 in your benzene ring can be converted to COOH by a certain reaction in your A2 notes. Okay, and then only once you have changed this to COOH, then only you attach bromine onto the ring. Okay, the reason why is because the bromine is sitting on position 3. 1, 2, 3. Okay, as you can see here in the example above, only COOH can activate position 3. CH3 will activate position 4. Okay, so why is it not the other way around? Why is the other way around not okay? Okay, now I'm going to show you if we were to do it the other way around. First, that's not, I'm just using that space. First, I have CH3. If I want to attach my bromine plus, my bromine can only sit on the 4th position. Okay, but here in my product, my bromine is in the 3rd position. That's why I cannot attach bromine first. I need to change my CH3 to COOH first. Okay, I hope you can follow this. Okay, the sequence matters in this case because of that position of bromine here. Okay, if you add bromine first, the bromine will be added onto that position, and that is not the product that we are interested in. Right? Suggested reagents and conditions for steps 1 and step 2. Okay, so that's me already giving you the hints. Okay, so that's question 5 to question 10. 11. Let me see. How many more questions do you have? Okay, you have 10 to 15. Most of this actually requires some of the things that, yeah, these are much longer. Okay, so we only have 6 minutes left anyway. So for Friday, your homework will be from question 5, okay, the one that we started discussion just now, up till question 10. Okay, so you do that for Friday. I'll have a look at question 11 to question 15. If I can give you the hints and then just assign it to you for Sunday, then I will let you know. Okay, do you have any questions before I let you go?
Do we have to look for the electron donating and electron withdrawing first?
For which group? For which question?
Question 7.
Question 7, this one. So for this question in particular, they don't emphasize on the position. So you can choose any position. Okay. If you want to follow the rules, you can follow the rules. But if you don't, that's also fine.
So if the question asks to draw intermediate, just draw intermediate only.
Yes, but this one, they want you to draw the products.
Okay.
So when they say, this one is not the mechanism. This involves two separate reactions. Okay, bukan, it is not one reaction and then 2 steps. So they are totally different reactions. So if you look at this, this one is a free radical substitution reaction. So you go from the reactants to product. Okay, you don't draw the intermediate, which is the carbocation. Okay, and then the second reaction is actually your nucleophilic substitution reaction. Okay, so nucleophilic substitution reaction is again a different reaction. So you draw the reactant to go to product. Is that clear?
Yes.
Okay, so you're not drawing the mechanism. Okay, so there's a difference between the reaction and the mechanism. If they ask you to draw the mechanism, then you will draw the intermediate, like, is it a carbocation? Is it the broken delocalization, and etc. Okay, any more questions? No? Okay.
The top apa nih yang SOCl2 and heat itu other topic other topic gitu.
Yeah, other topic, the next topic that we're going to do. Okay, so don't worry about that because we haven't covered that topic, but it just happens that it is the questions are combined, benzene and acyl chloride. Okay, even this one, tin and conc HCl, concentrated HCl, that is in the incoming in the upcoming topic that we're going to cover. So I give you the answer for now. Okay, do you have any more questions, Safina?
No.
Okay, all right. So if that's the case, I will let you go now. Assalamualaikum, and thank you, everyone.
Thank you, Miss.
You're welcome.
Thank you, Miss.
Bye. You're welcome.